EDA Builder 3.0, the complete library automation solution. With the industry's most advanced PDF datasheet extraction in the industry to extract complex PDF datasheet schematic symbols in a fraction of the time. Integrating the schematic symbols to the footprint automation with the most complete set of automation generators and calculators in the industry. And with the advancements to the 3D step automation, integrating the complete flow from the PDF datasheet and schematic symbol through the footprint automation and now the 3D step models. Let's start by bringing up the Footprint Builder component of EDA Builder, where we have the most complete set of advanced header connector generators in the industry, coupled with a complete set of surface mount generators, each containing a PCB footprint generator along with a 3D step model generator, with the support of through-hole devices including caps, diodes, dips, fuses, inductors, resistors, LEDs, and TO devices. Let's select a standard SOIC generator, where we will automate the PCB footprint models, supporting both the user IPC 7351 and user-defined dimensioning. Using the forms entry, I will select a number of pins and change the number of pins from 20 to 18, regenerating the component outline, along with the PCB footprint land pattern. Let's move to the 3D side views, where we have the forms entry for all of the 3D entry fields, where we can select not only the top view, but the front view and the side view. Selecting Export will export the 3D step model from this form or under Exports, linking the export directly to the Allegro package view. On the Allegro export form, we can build the step model, linking the step model to the Allegro part, and invoking the step viewer or 3D tool. Invoking the Allegro export, we will export the PCB footprint model directly to Allegro, and under Setup, selecting the step package mapping, we can browse all of the imported parts, each which has the proper orientation, X, Y, Z offsets, and match exactly the PCB footprint land pattern view. Moving back to the surface mount category of components, let's build and export an additional set of components. Selecting the BGA and the front view and side view, and exporting the part to the 3D step model. Let's move back and generate some additional parts. Under the new part, I will select the chip generator calculator and select the Cap C component type, visualizing the front view and the side view, and exporting the part to the 3D step model. Let's generate a third component, selecting the QFN generator calculator and changing any of the values in the forms entry, selecting the side and front view and building and exporting the 3D step model. This time I will select the Build Step, Export, and Browse button, which will invoke the 3D Step Browser or 3D Step Tool. In this case, the 3D Step Tool is Autodesk Inventor. And selecting the 3D Step Model for the BGA package, let's browse the package that we previously generated with the 11 by 11 matrix. Moving back to the import, let's import several other step models previously generated. Selecting the cap component, notice that the 3D model is auto-generated with user-defined color patterns. In this case, we selected orange for the capacitors, blue for the inductors, a brown color for the transistors, and other user-definable color patterns. Browsing the CQFP, notice the automation of the marker code for the pin 1 and the orientation. Next, let's bring up a DFN part with the different leads, sizes, and widths automatically generated, matching the PCB footprint land pattern model, which we exported to Allegro or a host of other EDA tooling systems. Selecting the diode part, notice that the user-defined color code is red. And bringing up an LCC part, notice the automated corner chamfer in the upper left corner matches the original datasheet definition. These are only a few examples of the detailed 3D step models which can automatically be generated with the EDA Builder product. Browsing a few remaining components, let's review the PLCC component and a few of the other components, such as a standard SOD component, or an SLT component. In addition to the SOIC family of components, EDA Builder has a complete range of commonly used through-hole generators, including the DIP component family, axial lead generators for caps, diodes, fuses, inductors, resistors, and other component devices, and radial lead generators, and specialized devices such as this TOC generator. EDA Builder 3.0, the complete library automation solution. From the PDF datasheet, through the schematic symbol generation and automation, with integration to the PCB footprint generation, and the final step, the 3D step model automation. Thank you, the EDA Builder development team from EMA Design Automation.